So what we're going to focus on now are the application framework and apps layers of Android, or application layers of Android. So first, I'll give you a quick summary of what an application framework is and try to motivate quickly why they're useful. And then we'll also talk about some of the common system services that Android provides in its application framework layer. And I'll also, just for fun, summarize some of the common apps. You guys undoubtedly know all these things. Even if you're not an Android user, you probably are familiar with these kinds of different capabilities. So first question is, what is an application framework? So a framework is basically an integrated set of components, classes, functions, whatnot, that provide a reusable architecture for a family of related applications or related apps. So the key theme here is it's an integrated set of things. They work together. It provides a reusable architecture. You can keep customizing it for other purposes for a family of related apps. Now, as we'll see, there's lots of different characteristics about frameworks. They typically, for example, have certain properties, which we'll talk about in more detail later, but we have properties like inversion of control, where you register callbacks that are dispatched when events of interest occur. So the framework is responsible for managing the event loop, and it calls back on your handlers or runnables when something occurs that you've registered your interest in knowing about. They also are typified by domain-specific services and capabilities. So, for example, Android is the mobile app domain. You might even more narrowly think about, say, the concurrency domain. So there's a bunch of ways of handling concurrency in mobile apps and Android. And we'll talk more about those briefly here and then more next semester. And the third thing that an application framework has is it basically has this semi-complete nature. So there's an awful lot of stuff that comes out of the box for free, especially with Android. There's no extra charge. It's not free to, it's free to you, the user. It's not free to everybody, but it's free to you, the user. Google actually makes a lot of money with Android in other ways, but charging the users for using it is not the way they make their money. And as a result, you don't have as much work to do to make applications. Here's a quick summary of how control flow occurs in a framework. So frameworks are typically based on what are known as event-driven programming models, where you register these event handlers that get called back when things occur that the framework detects on your behalf. And this is convenient because it allows you to be able to plug stuff into your apps. The reason for doing this is it makes your system more reusable, and it provides canonical structure and functionality. So once you start writing Android apps, they all kind of have a common look and feel to them. I should also hasten to note that there's different generations of Android apps, and Google continually adds new ways of building apps. But if you strip away and look down at the core, they all have this framework nature to them in order to make things more systematic. So here's typically how these things work. An app or a service will register callbacks, which are usually objects, for specific types of events that might occur within the framework. So there's this registration phase. So a callback is basically an object. It can be passed as an argument to a framework, such as the activity framework that comes as part of Android. And the framework then monitors various event sources. This might be network connection. It might be the user pointing, touching on the screen, for example, clicking by pressing some kind of user interface widget in some way to interact with the screen. The framework monitors the event sources for activities of interest, or events of, I should probably say events of interest. So an event occurs, and what will happen in that case is that'll cause the framework to call back to the application code, to the object in the application code. So when an event of interest occurs, the callback takes place, and then the app does something in response to that callback. So it might, download a file, or it might render an image, or it might display a web page, whatever it's going to be doing. it'll do that processing. And the processing takes place usually out of the box by borrowing the thread of control from the framework. Now, that comes with certain pros and cons. If you borrow the thread of control from the framework, then either the framework has to have a pool of threads that it uses so that things don't get starved, but then that makes your application code multi-threaded, which can be complicated. Or it will end up blocking the framework for the duration of the callback, which means that if you have a long-running callback, you could end up keeping the framework from servicing other sources of events. So we'll see later, we won't talk a whole lot about it now, but if you take next semester's class, we'll talk a lot about how Android provides all kinds of clever ways of taking long-running operations that are initially detected and dispatched in the user interface thread, which is what's running this framework code out of the box in Android, and handing off the work, the event, to some other thread from some other location, either a thread that you spawned or a thread from a pool of threads like the fork join pool or a thread pool executor or other things we've talked about in the context of Java. So there's all kinds of other ways of being able to process these things without causing the framework code to be blocked indefinitely. After the callback is finished, control returns back to the framework, where the framework then waits for the next thing to happen. And this just keeps going on and on and on, right? So it's lather, rinse, repeat. If you want to amuse yourself, take a look at the Wikipedia link for lather, rinse, repeat, which is somewhat humorous. OK, so that's basically what a framework does. I will talk in more detail about frameworks later before the class is done, and we'll go into more detail. Understanding how frameworks are designed and how they behave is extremely important when you program with modern software environments, modern platforms, because almost everything these days is built as a framework in one way or another. And that's because nobody wants to write everything from scratch. So you have to end up reusing large chunks of infrastructure, and those chunks of infrastructure typically rely on callbacks in one way or another to dispatch objects that you create to inform you when something the framework detects has occurred. So it's just really important to get your head around that model. Everything works that way. That's probably quite different, I'm guessing, from most of the programming you would have done in a lot of the intro courses here at Vanderbilt, where much of your application is self-directed. The application decides what it'll do and when it'll do it. Whereas with the framework decides when things will happen and calls you back to do something. So it's called inversion of control. It kind of stands you on your head thinking about things architecturally. So the application framework layer contains a bunch of system services implemented with frameworks that provide apps with all kinds of capabilities and information they need in order to be able to do their work. So here are some of the things that you can do with the application framework layer. You can expose the low-level stuff down here, which you would never program directly because it's written in C. You expose this up to applications in a higher level manner through objects and events and all that kind of good stuff. And if you look here, you'll see there's various services that do this. So there's a thing called the telephony manager, which is used to keep track of phone calls. When do they start? When do they stop? How do you get notified? How do you know when the phone is ringing? How do you, do all the various things you need to do to manage phone calls and merge them and so on. There's also lots of stuff here to keep track of your location, to notify different parts of the Android user interface when things occur, like you get a new email message or a new text message. You have to be notified and alerted so you can indicate visually to the user something's happened. There's a window manager. If you're familiar with newer versions of Android, you can actually have windows that are split. It used to be you only had one window on the screen at a time. Nowadays, you can actually split many applications and actually have sort of like multiple windows. It gets a little bit cumbersome because there's not a lot of screen real estate unless you get like a Note 7 or something like that, really big, or a tablet. So these are some of the things that you get here that give you a higher level way of accessing the low-level hardware-specific or hardware-centric kernel capabilities. Something else that the application framework does is it gives you a bunch of services that run continuously while Android is up and operating. So for example, your window manager is always running, or at least it always should be running. Your telephone manager should always be running. Keeping track of your location should always be running. There's some other things like the activity manager we'll talk about in a second that should always be up and running. And so a lot of these system services are specially designed so if for some weird reason they were to be shut down or crash, the system monitors them continuously and then restarts them automatically for you. That shouldn't be happening on a regular basis, but they have to build the system to be resilient to account for the fact that sometimes things go wrong. And of course, because this is based on a framework, control flow is driven by events and callbacks. So you register stuff and then the framework layer calls back your stuff when things happen. Most of the system services are written in Java with some C and C++ native code. So you can actually go and look at the Android source code and see all the various system services that are there. They're really quite interesting. One of the most interesting ones, and we'll talk about a lot of them later, but one of the most interesting ones is something that's called the activity manager, which is actually kind of a misnomer because it does a lot more than manage activities, but it actually manages activities, services, and broadcast receivers. And it's a really gigantic file with a couple of other helper files that is written in Java, but it might as well be written in C because it's not very abstract. But it's pretty cool, and we'll talk about it later because it's sort of the workhorse for an awful lot of things that go on in Android. I should also mention that the activity manager implements all kinds of cool patterns, and the most obvious one would be the publisher-subscriber pattern, but there's other patterns lurking in the activity manager service as well. The author of the activity manager service is a lady by the name of Diane Hackborn, which I always thought was like a really cool name, right? If you're going to be a programmer, you'd be like Hackborn. And either that or it sounds like a villain from a Dick Tracy novel, because they always had interesting villains. But anyway, she did a lot of the core implementation of Android's infrastructure and very knowledgeable about the internals. On top of all those services, which we'll go into more later, there are the apps that we use every day if you're an Android user. These include things like SMS, MMS, a browser, your phone, your camera, anything that you see as a little icon that you can click on is pretty much an app. The bulk of these apps historically have been written in Java. In fact, I believe everything that's in Android out of the box is written in Java, all the apps that you get out of the box with the AOSP, the Android open source version packet. What does P stand for? AOSP, Android Open Source Project. That's what the P stands for. So that is all written, those apps are all written in Java. It's possible to write apps or large chunks of apps in C and C++, although not widely advised. It's possible to do it, but it's not common. And more recently, in fact, if you take a look at the bulk of the app portion of our image web crawler app, or the one we've been using as the driving demo application for all the assignments, all the app code is written in Kotlin. All the image management code is written largely in Java, the stuff that's doing the concurrency and so on, but all the app code is written in Kotlin. And that appears to be a trend. More and more people are learning Kotlin and using it to write apps in Android. Has anybody here ever written anything in Kotlin? So it's a really interesting language. It was developed by a company called JetBrains, which are the same company that have released the IntelliJ IDE, which is also the basis for Android Studio. And they have a real tight relationship with the Android developer community. And you can basically think of Kotlin as kind of a better Java, maybe in much the same way that some people might consider something like Swift as a better Java, although that's a bit more arguable. But the point is that it's a language that kind of sands off some of the rough edges and sharp corners of Java. And if you program in Kotlin, there's lots of things that are sort of quirky in Java that just disappear altogether in Kotlin. Obviously, under the hood, Kotlin leverages all the Java runtime environment. So it's really easy to call out to Java code from Kotlin. And in fact, Kotlin is basically a JVM-based language, so it'll turn into the underlying Java bytecode, which can then be run on a Java virtual machine, or the Android equivalent of such an execution environment like ART. But it's pretty cool. I haven't really had a chance to learn it in great detail, but my colleague Monty, who has written large chunks of the assignment driver code, is a huge Kotlin fan. So I decided it was better to let him have lots of fun than me try to write it all in Java. Yeah?
Used anywhere else, or is it?
It's intended, so question is, what's the scope of Kotlin? Kotlin is really a general purpose programming language. You could use it anywhere you use Java, you could use Kotlin. For various reasons, they've chosen to focus a lot of the newer Android development in Kotlin, although Java also works fine too. But I think that's predominantly where it's used. It's kind of fun. If you've ever gone to the website and you search for TOB, in fact, let me show you this. So that's the end of this particular part.